Welcome to Deep Agents by AI Makerspace. Today, you'll learn what a deep agent is, or ambient agent, or long running agent, what those are. You'll learn the 4 characteristics that make up a deep agent, including a detailed system prompt, planning tool, subagents, and file system. You'll learn what makes a deep agent different than a shallow agent, and when you should think about using one or the other, how to build with the deep agents framework from LangChain, and how to think about building deep agents with any framework that you might pick up off the shelf. As we do every week, over the next hour, we'll dig into the concepts and code behind this topic. Then we'll build, ship, and share an LLM application live. I'm Dr. Greg, and after spending a decade learning engineering in academia and teaching engineering in academia while working with real companies, I saw that practical success in the 21st century required a much different approach to professional training. That's why we built AI Makerspace. As always, I'm joined by my co-founder and CTO, Chris the Wiz Alexiak. We call him the LLM Wizard around here. All right, Wiz. So deep agents, what's the crux here? Is the deep just about like how lost in the sauce the agent gets? What's really going on?
I mean, basically, yes. The deep referring to depth, just how hard it goes to the paint trying to find an answer or do a task, right?
That's right.
We're not just one iteration deep. We're many iterations.
Is it all about time? Is it all about tokens? Is it all about like, multi-agent systems? Like, is it all about all of the above? Is it just, is there a way to compress this easily?
If you have a task and you go 6-7 layers deep digging to try to find the response, right? You've probably got a deep agent on your hands. If it's happening quickly, that's better than if it's not happening quickly.
We'll snap judgment.
But that's it. The more you dig, the more akin you are to a deep agent.
And as we've talked about on this channel before, like not everything requires you to go super deep. Sometimes you just need a quick snap judgment, but other times you got to. I mean, you want to figure out the truth, you want to get it right. Sometimes you need to go deep. Now, is this related to kind of memory across conversations, or maybe sometimes not necessarily?
I would say at the end of the day, what we want to think about with any of these deep agent systems or agent systems generally is we're just getting started with understanding them. We're just getting on the track.
That's right. That's right.
We're in the year of discovery, decade of agents.
That's right.
Whatever meme language you want to use, but
that's right.
We're just at the tippity top.
That's right. And that was what I was struck by, as we'll see today, is that this is a great sort of step along the steady drum roll of agent engineering discovery, but it certainly by no means is comprehensive in the end all be all. A great next step for everybody to take, going deep with agents. I'm looking forward to getting into this. You ready to rock, Wiz?
Oh, yeah.
All right, let's go ahead and kick this thing off. Welcome, everybody, to another AI Makerspace weekly Wednesday event. I'm going to go ahead and get us started here with some slides. As always, the slides and code will be shared for everybody. All right, so deep agents. This is a LangChain framework, and today, as we mentioned, you'll learn the core components. You'll learn what a deep agent is. You'll learn how to build, ship, and share with the deep agent framework. So let's get into it nice and easily with the right context. So in order to talk about deep agents, we want to kind of put shallow agents in context as well. And I really want to zoom in on the importance of planning. It's a key feature that we've noticed, not just in a lot of the work being put out by the large model and agent labs, but also by a lot of the learning that's happening in our courses with our students as they do ever more complex agent engineering in their projects. And then, of course, we'll build a deep agent. So deep agents. So the idea is naive agents are shallow. You might say they're a little pedantic, even a little shallow. So we might want to ask the question, like, what is not shallow exactly? And we can answer this very clearly if we stick with a kind of simple core foundational case. Let's consider just LLMs. Okay. Let's consider back in the day when LLMs came out, we started prompting these things. When we told them to think through step by step, we're being a little bit less shallow. When we started to see in early 2025 models come out like DeepSeek R1 that would think before they answer, this is going to be a little bit less shallow. We also have seen models released like Claude Sonnet 3.7 that could do the near instant responses or could do extended step-by-step thinking, aka reasoning, and they could kind of do both. And as we've seen many times, looking at models like this on this channel, if we have this reasoning capability and we go through these reasoning steps, we can get better answers when we're solving problems that require reasoning. This reasoning pattern is typically followed by doing something when we're talking about agents. This reasoning and then taking action, even back in 2022, when this React paper came out, we were talking about using reasoning to update plans. Again, this planning idea being a key here, and then taking actions. So we kind of have this idea of thinking, of reasoning, and of planning. And this is kind of important as a precursor when it comes to going deeper with our agentic systems. We can talk about what the blog on deep agents says exactly. The simplest form of an agent can yield agents that are shallow, i.e. they fail to plan and act over longer, more complex tasks. So we might characterize this as like, how much time are we spending thinking through things, planning, reasoning before we go and we act? And that kind of gets us into this ballpark, into this realm of talking about test time compute, or time spent thinking, or amount of compute spent doing inference. But this is a spectrum, okay? Because we might also look at the other side of the spectrum, and we might ask, like, but could we go too deep, right? And again, like for LLMs. And as we've seen, this year is reviewed on this channel, like, well, at some point, it's like, yeah, you went too deep. And this was like the illusion of thinking paper from Apple. Maybe it's a specific type of game. Maybe it's a specific type of problem you're talking about. But there are situations where you've gone too far. You've thought yourself down a rabbit hole. So Wiz, maybe we can talk a little bit about this idea of the right amount of thinking, and that kind of gives way to planning. But how much thinking do we need for any given application that we're building? This is a common thing that we have to decide on now: high thinking, medium thinking, low thinking, even just choosing the LLMs and the mode to put them in when we build apps. Is this related to deep agents in general? If we're building them, should we always go deep? How do you think about this?
I mean, planning is important for any process, right? So, while we can obviously center it in deep agents because we're talking about them today,
Yeah.
Planning is useful for all agents, deep, shallow. Having a good plan means you have better, means you have better outcomes. I mean, there's no reason to say avoid planning, but the idea is that if we want to have this really kind of long horizon of tasks, right? We know we're going to be working for a while, then having a plan to kind of ground us as we move through tasks is going to feel much more important. So you need to plan no matter what you're doing. I mean, in real life and agents, and it's felt more and more the longer horizon or task horizon you have.
In real life too. Yeah. I mean,
I know.
yeah, it's like, yeah, I mean, you fail to plan, you plan to fail. Classic. So is there sort of a sweet spot of reasoning that we should be thinking about using when we're building deep agents? Like, should we tend towards using reasoning models over non-reasoning models, or is there any sort of key heuristics we can keep in mind there?
Yeah, you should definitely use reasoning models if you're talking about planning, for kind of the same reason, right? Reasoning models are good at thinking about steps over a longer time horizon. So it makes sense that they would be better at planning things over that longer time horizon, right? That idea of like chain of thought is thinking through step by step. I mean, what is a plan if not step by step actions that you should take? So ultimately, yes, reasoning is definitely a boon to planning, just in an absolute sense.
Okay. So you're saying actually you would prefer to separate planning from this idea of deep agents in your sort of conceptualization of the idea of deep agents. Is that right?
That's right. Yeah, I think about planning as a universally useful thing to do, with sufficient complexity. Now, this can obviously mean for deep agents, but shallow agents that are working on complex tasks are also going to benefit from a plan. I think though, if we have like a gradient, right, from benefits the least from planning, or to
Ah,
benefits the most from
yes.
planning, these really long time horizon tasks like deep research are going to benefit disproportionately long or more.
It seems like, and again, we're out here on the edge, so we're just kind of figuring things out together here. It seems like the conceptualization of and this is from July, quite a long time ago at this point, like from Harrison, is that it is shallow means fail to plan and act, though, and act here over longer, more complex. Like, so is it the and act part that sticks out to you, or is it is it just that maybe this is not the most robust definition that we come up with for deep agents today?
I think it's uh, the shallowness or depth, right? I think
Yeah.
planning rears its ugly head when we're talking about complex tasks that require step-by-step plans. This doesn't mean they need to be deep, right? Having the
Yeah.
right plan, like imagine you're trying to solve a question. Step one is like critical, but there's only 3 steps. I mean, planning to do step one correctly first is still going to benefit you tremendously.
Yeah.
I think though
Yeah.
that when we talk about shallow agents, it may necessarily omit planning in the definition provided, right? So of course, if you say shallow agents are agents that do not plan,
Well, yeah, I mean, I
then
don't think it's that explicit, but it's basically that, yeah, I mean, that fail to plan and act. So it's kind of
yeah,
like it's like is it it's kind of like the large language models problem. When does the large become a small language model exactly? When does the shallow agent become like I just made a little plan agent, as we move forward? Um, I just want to point this out because it's so interesting how quickly the space is moving. And as we'll see in a little bit, like this was kind of inspired by Claude Code, since it was inspired by Claude Code and put out, Claude Code SDK has become Claude Agent SDK. They've added another piece to their thinking about how they built Claude Code. And so it kind of filters all the way back down. So no one should basically take anything from any of these things as gospel for all eternity. We should stay critically thinking about each and every piece of them. So
I think it's really important, right? Because as we get, I mean, we're in the middle of a revolution all the time with reasoning models, with LLMs, with whatever AI is going to do next, right? And as we get more and more capable, faster and faster models, models that don't even necessarily need to be thinking models to be excellent at planning, or models that think extraordinarily quickly, and so we can shove them into more parts of the pipeline, right? Like these definitions are a product of their times and the current technology, right? And so what we call a deep agent in 2025 is probably going to look very shallow to what we call a deep agent in 2026 at the same time of the year. We're going to look back on these deep agents like we do the React pattern, right? Where it's like, React? That's so easy. That's so, that's nothing. But when it came out, React was king, right? There was nothing better.
Right. That's right.
It's a constantly moving, field, and the definitions necessarily shift as well.
Yeah, they break, and the workflows of 2026 are going to look hella agentic versus the workflows of 2025.
Yeah.
Okay, good stuff, Wiz. All right, let's keep it moving here, guys. So there's this key idea at kind of the top of the docket here about simple agent. So we just kind of basically walked the path of adding less shallowness, but not too much depth to a single LLM. Now, what happens when we give that LLM a tool? Well, when we give an LLM a tool, it becomes an agent. And when we run it in a loop, it's definitely an agent by the modern standards of definitions of agents. That is, an LLM agent runs tools in a loop to achieve a goal. This is very similar to what we see in the deep agents blog from LangChain. Using an LLM to call tools in a loop is the simplest form of agent. We sort of have talked about this for some time as we're just giving the LLM access to tools. That is to say that when we give an LLM access to a tool, boom, it becomes an agent. And so you can kind of think about this very simply. The LLM, it's got tools. It can decide to go reason and act on those tools and then put that back into its context. Kind of like a superhero picking up tools in its tool belt. Which tool am I going to pick? How am I going to solve the problem that I have with the bad guy? So this idea of this core agent loop is now, yes, it's table stakes and it's beneath kind of the level of the deep agent, but it helps us to understand where all this is coming from and where it's headed. When we go to our agent, it can take an action. It's going to consider that action before it produces a final response. That action might be a tool. It might be a collection of tools, might be MCP servers and a whole bunch of tools. It might be a specific tool and workflow that another agent runs. It could be all sorts of interesting stuff. But we do see this kind of core pattern at the center, this React pattern that is now very not the hottest, newest thing, but that we see over and over again. And we put stuff into our context window, aka into our conversation thread. So this pattern is basically kind of doing this, we might say a little bit naively, doing this a little bit shallowly, because we're not really planning in that simple agent loop over long time horizons or to do extremely complex tasks. We're really not doing that there. Really just kind of hitting a tool and letting an LLM run and put stuff in its context. Whereas when we look at stuff like research, we look at stuff like async coding, these two areas, specifically in 2025, have emerged as productizable. All of the major providers have a deep research offering. Pretty much all of the major providers have a way for you to integrate with their specific coding tool stack. And we're seeing more and more folks come on to that coding scene, even with their own CLI specific coding tools that they've trained up. And then, we're seeing more and more startups emerge into this space. And what LangChain is seeing is they're seeing their customers build their own versions of these tools, and many startups build domain-specific versions of these tools. One of the things that I've noticed with enterprises is that a deep research tool for your specific company is about as useful as ChatGPT for your data was in 2022, 2023. These are incredibly useful tools for people around your company to be able to find the right information throughout the company. Imagine how much more quickly onboarding takes place when a new person has instant access to every piece of information that your company really has to offer. It doesn't take years and years of working there to kind of start to understand some of that core foundational proprietary stuff. And so you see all these tools from OpenAI came out, and they kind of piggybacked on top of Google, Perplexity, Grok, as we'll come back to. The open deep research from LangChain was released. All these things were released in just the series of a couple of weeks in February this year. Claude research came out in April. Mistral came out in July. And deep research is now officially like a thing. And if you're out there building agent applications and you say, could ChatGPT do this? You're often kind of saying, could a deep research tool do this already? And you may want to consider adding, a bit of a deep research flavor, a bit of a deep agent flavor to some of your agentic systems as you build them. But it's not just deep research. It's not just docs and enterprise. Specifically, the biggest thing has been coding. And so on the coding side, we see lots of tools like this, deep research-esque coding tools like Claude Code, like Codex from OpenAI. That's their sort of brand of coding tools, like Cursor from AnySphere. Now, Cursor has their Cursor CLI tool built in when you first download it. No longer do you have to connect it to Claude Code. They're everybody's kind of becoming their own thing. It's also the A-Suite guys, right? The people building out your autonomous software engineers like Cognition and Devon. These are the guys that acquired Windsurf and also Manus. And these are people raising hundreds of millions of dollars and doing stuff that is, really, really exciting in the software engineering piece. So to kind of open up this next discussion piece, I just want to this isn't just, as we talked about, an AI specific thing. This is like well known in life, right? Like we want to plan all the way to the end because then we'll know when we need to stop. And Wiz, I was so struck by the way that our students have been learning this lesson in class. Like they came to us and like yesterday, they're like, hey, I finally did this, big project. And I realized that I put in all these hours, so many hours, and all of it kind of came down to ultimately I had to throw everything away and kind of use everything I learned in the markdown files, in the final plan, and then kind of one-shot it at the end. And this kind of like supreme effort in iterative. Okay. You're not just thinking in a vacuum. It is iterative, but it's this iterative kind of agentic planning that's happening through failure that then results in the final plan that you can then execute to some sort of level of, yes, I finally got it. And the AI slop is minimized. The slopification of going back and editing stuff is minimized. The searching and researching and then trying to take all these different researches and compress them together is minimized. And like, and it's like this kind of planning, I just want to triple down again on it. Like it might be the most important piece of this Because if you do it right, it kind of looks like it's all easy at the end. I don't know. Like, it's amazing to see our students come to us and say, hey, I struggled for 10 hours and then the thing took me 30 minutes.
Yeah. I mean, it's really in real life, it's the same way, right? I mean, we want to, it's like set yourself up for success, right? There's so many memes about planning that we have that are kind of like in the zeitgeist, right? As we famously from the A team, one of their superpowers is that like they could plan well. I mean, it's unsurprising, but the idea is if you set the initial conditions such that you're likely to see success, you're more likely to see success. It's just that easy, right? If this is no different when we're talking about the deep agent itself, right, or the agent itself. Coming up with a good plan first is important, and it's also no different if you're talking about using AI or leveraging AI, as our students were talking to us about, right? Which is it's really important to set everything up so that all the context you need to solve the problem exists right in front of you. It's really important to set it up in a way that allows us to quickly, address any missing information, right? So, anyway, this is exactly what we see on the screen. Failing to plan is planning to fail. This is no different at all, just because we have autonomous systems. Same.
Yeah.
And the more planning we do, okay, we're going to get meta for a second.
Okay,
The more planning we do, when we're planning, our agent's ability to plan,
the meta plan,
the more likely it is to see success, right? Like the more time we spend deeply in thought and iteration on how to make sure we come away with the best step-by-step plan. I mean, you look at tools like Cursor and Claude, which have been iterating very quickly and extensively on their agents' respective abilities to plan, and it's come with great success. People have emphatic and positive response to things like planning mode because it really is that easy. You just need a good plan.
Yeah, I mean, like, I'm struck by like what does the future of kind of software engineering look like, or any of these jobs, right? It's kind of saying like, hey, we have to think through what the hell we want the system to do, what the hell we want it to search and research, what we want it to code, what packages we want it to use, what packages we don't want it to use, what reference material databases we're allowing it to use, which ones we don't want to allow it to use, what keywords we're looking for, what fuzzy matches we're looking for, what sort of specific anti-slopification practices we're going to employ in our writing we generate or in our coding we generate. Like, this formulation with enough clarity, I think, is something that when we get to deep agents, it starts to become more clear that we cannot just allow the AI to do it for us. Like, and then what we'll see, and what Claude Agent SDK showed us that we covered the other week, is there's another layer at the end of this, at the end of this agent meta loop, which is called evals. And it's like, well, and then you just could have what? The LLM plan the whole thing and then eval forever on the whole thing. Like, it's really about thinking this damn thing through, because I think that's going to be all of our jobs, right? I mean, it's like, I don't know, I'm getting on my soapbox here a little bit, but it's like, it just feels like as we get into deep agents, it's even more dangerous to just, hand it all off to the AI. And that's,
I mean, exactly so, right? I think people have this misconception that you're touching on a little bit, which is we don't want the thought to be, well, my agent is going to be able to work for 10 hours, so I can continue to treat it like something that worked for 3 minutes, right? Like when we had initial ChatGPT, we're just prompting, we're in a tight loop with the system, right? And now it's like, oh, I'm going to kick off this thing to do like 10 minutes of work. I'm going to spend the same amount of time as if it was going to do 2 minutes of work, right? And we kind of fall into this anti-pattern of not investing more time into the initial conditions, right? So I think you're exactly right that as these systems get more and more capable and can work over longer and longer time horizons, our planning, our input, this is to say nothing of the actual systems planning, needs to be, in some way proportionally increased. And I think that's it's good insight in how you should think about using deep agents. They're not for tasks that you just go, I don't know, I kind of want a new shirt. Deep research.
Yeah.
They're for tasks where you're able to think deeply about the problem and define it well and provide the initial conditions for success. And that's going to necessarily take more time. It's going to take way less time than the actual deep research to run, to be very clear.
Yeah.
But it's still gonna cost you time in order to get a response that didn't just waste 10 minutes of your life completely.
Yeah, I mean, it's it's so interesting, right? It's like the actual hard reasoning needs to come from us before you set this damn thing off down its path. Otherwise, it's just going to get you into trouble. And it's never more apparent than in the AI assisted coding paradigm today, where we're just seeing students struggle with it like never before. Like never before. And
It's
it's
intoxicating, right? It's
yeah.
when you can press 3 buttons and something that mimics intelligence goes off to work for 15 minutes, it feels good. When you see all the lines of code rolling through, it feels good.
Oh, it does.
And the same is true of the agent system, right? To bring us back into a little bit from the meta problem, like the same is true of the agent system. And this is why things like context engineering are so important, why we need to make sure we're very selective about what pieces of context, what stage of our agent can see. This is especially true in deep research, where we're going to have an oodle of totally useless context, right? That fills up our context length very, very fast. And so that context management, we need to measure it, but also the agent needs to as well. And that's something that we won't be moving away from soon.
Yeah. Okay. So let's go ahead and connect some dots here to make it clear what the framework is and where it came from, and then let's build something with it. All right. We'll see you back shortly, Wiz. Okay. So here's the framework, and we'll come right back to this. I want to just point out this project was primarily inspired by Claude Code, and initially was largely an attempt to see what made Claude Code general purpose and to make it even more so. As we saw when we covered the Claude Agent SDK a few weeks ago, Claude Code has become far more than a coding tool. At Anthropic, they've been using it for deep research and lots of other things that are not coding apps. They went on to say in the blog that while many of the use cases that were not code were predictable, others were kind of surprising. Lawyers building phone tree systems, marketers generating hundreds of ad variations, data scientists creating complex visualizations without knowing any JavaScript. Agentic coding is dissolving the boundary between technical and non-technical work. Anyone who can describe a problem can build a solution. And so this new collection of tools called Claude Agent SDK allows us to sort of build out, let's say, these deep agents, we might say. And it's instructive to look at this agent SDK loop. The first piece of the loop is to gather context, which is a heck of a piece of a loop. There's lots of loops in there already. Then to take some additional action, and then to verify. And this is that evaluation piece. We can loop through this, and we'll see the core agentic loops happening within this. Just briefly on this first piece of gathering context, this is an important line here. Agents need more than prompts. Like, what do they need? Well, they need agentic search and a file system. Look at that. The folder and file structure might become something super useful. What else do they need? They need sub-agents. Oftentimes, those sub-agents have specific roles or personas they're supposed to go uphold or fill. This isn't just another parallelized research agent amidst a deep research application, it might be something even more specialized. Now, after gathering context, there are many other pieces of gathering context that we covered in that event. For today's purposes, those are the two that matter to us. We can take action. For example, hit up a tool, right? So now, as we're starting to see with kind of the quote unquote second wave of MCP, a tool, or we might say a meta tool, could actually be an entire workflow driven by agents with access to tools that is more like, go build this program for me that does this thing, rather than here's a bunch of tools, go figure it out. So tools is starting to expand in its definition as well. We can create endless iterations of different types of tools. Just imagine all of the different meta tools that we might be able to create. And then, of course, there's the eval piece that is sort of beyond the scope of today's discussion. What I want to point out here is that we covered this in that event. And if we zoom in way up here to the left, we can see in the gather context piece, amidst our sort of meta reasoning action loop, we have little reasoning action loops, and calling tools is little reasoning action loop. So we have all these loops. We can see that, yeah, there's this evaluation piece, and that's dope. But there's also these two pieces. What are they? Let's zoom in here. Oh, we see agentic search in the file system, and we see sub agents. This is exactly in line with what this deep agents framework was putting out. There's a couple other things to point out here before we get to the demo. The creator of the LangChain open deep research repository, that is Lance Martin from LangChain, points out in a great blog where he sort of talks about the evolution of that deep research system, that the design philosophy for building AI apps is still in its infancy, as we've discussed at length today. So it's not just about, research with planning and then parallel sub agents like we saw from Claude Code. It's not just about using a reasoning model to do the plan, splitting it into sections, and then smashing it all together. In fact, the first iteration of Open Deep Research looked something like this, where there was a plan written, it was decomposed into sections. Those sections then were written each independently, and then they were aligned and compressed in a final report. Now, this resulted in a report that looked like a bunch of different people wrote parts of it, and then it was smashed together, which is just a report that's not that dope. Nobody really wants to read that. That's the kind of a report you just turn into somebody that isn't going to read it. Whereas if you, again, follow this pattern that we've been talking about today, you plan it to the end, you iteratively struggle through this, you realize what the plan should be, you realize what the bounds of the plan are, you set up your optimization correctly, you flexibly plan, you probably run a couple tries, you fail, you reorganize the plan, you get it right, and then the scoping and the research, importantly, are now disconnected from the final step, which is the writing the report in one shot. Or as we talked about with our students in class, it is the actually creating the application in one shot once you get all of the AI-assisted markdown, rules, tests, and everything set up. And so, Wiz, this final discussion here before we get to the demo, is planning and then one-shotting like the move in general here that we should just be using all the time? Are there any other useful patterns that we should be considering when building deep agents?
Yeah, tons. I mean, this is another great question because it uncovers, all the different ways we're exploring agents. I mean, planning and one-shotting is like the ideal, situation, but it's almost certainly not going to work out every time. Allowing your agent to kind of come up for air with and request feedback or see if directionally we're on the right path, or at the end of every step that we've planned. All of these things are good ways to continue to gather information as you run through your deep research tasks or your deep agent tasks. For something more shallow, like just deep research, for instance, maybe that's not as necessary. But for tasks where we're doing work, we definitely want to allow the agent to receive feedback more than one shot. One shot's a little risky without constant supervision.
You only get one shot.
One shot.
Deep agent. Did you just say deep research is a shallow agent? Now I'm confused. I suppose this is
Listen, it's a
part of
gradient.
the whole thing. Okay.
It's a gradient. The top of the water and the bottom of the ocean. There's a lot of space in there. They're all deep, but some are more shallow than others.
Yeah, so maybe it's a shallower deep that we're talking about. We're just merely deep researching. Excellent.
That's right.
I believe you have an example of something that kind of walks us through what this might look like.
No way.
Building a deep agent. There's 4 component pieces, Wiz: a prompt, a tool for planning, sub agents, and a file system. Things we've heard about today. Guess what? System prompt inspired by Claude Code. To-do list inspired by Claude Code. Sub agents, and people won't be surprised that follow our channel, a virtual file system leveraging the agent's state. Classic LangGraph. Wiz, why don't you go ahead and walk us through what it looks like to build, ship, and share some deep agents?
Oh, you know. Okay, so what we're going to do is talk about the deep agent in LangChain AI's open deep research repository. This is one of my favorite repositories. No jokes. If you're like, what deep agent, what do, this is the best place to learn. First of all, what we saw from Greg was an older diagram. This is kind of the new way to think about this open deep researcher. We see this very familiar pattern, right? We scope out some kind of request, and then we ask the user if good. If good, then we move on to the next stages. And you can see that the depth really comes from this stage here, right? So we talk about deep research, or we talk about deep agents or long-running agents, or whatever way you want to conceptualize deep agents. The idea is the longer we can sit in this loop, right, the more quote-unquote depth we're going to explore. Now, this is maybe perhaps actually best illustrated as width in certain scenarios, but the idea is that we're going to sprawl out the most, right, if we find ourselves doing a lot of loops in here. This is configurable for some systems. You can configure an explicit number of loops, or you can configure, maybe just a cap on the loop. So the idea is pretty straightforward. We ask the user to clarify what they want to learn. We generate based on what their clarification is, and then we pass that to the research supervisor, and we see this pattern, right? We're going to go to supervisor tools, supervisor tools, supervisor tools, supervisor tools, until we are done. When we are done, we generate a report. This piece, right, ultra shallow. This piece, giga shallow. This piece, very deep, right? So the idea is that our deep agent, really, we're talking about like a pretty specific subcomponent of our agent that's giving us that depth. So let's look and see how this thing is actually built under the hood. We're going to look at the new version. We're going to look at some of the prompts. We're going to look at our state, and then we're going to look at deep research. So our prompts, like Greg said, based on the old Claude models, you're going to see that these are some pretty beefy boy prompts, right? We are providing a lot of information, and that information is largely necessary. So sometimes I might figure out what the date is. I need to know what I need to know in order to understand reality. So these prompts have to be huge, and they have to contain a lot of information, and it's all useful, right? So this is the first part of context engineering. Then, of course, we have prompts for our subcomponents. Again, we're being very verbose. We're being very, very verbose, right? You'll also notice that we're using this XML format, where we're using our opening and closing braces as opposed to Markdown. If you're not doing that already, get doing that. It's the best. The idea is, though, that for every single component, we have an extensive prompt, potentially with some examples that has only the context required for this stage to absolutely rock it. Next, we have our actual state. Now, our state in this case is pretty simple, honestly, right? So if you're used to LangGraph, state's like kind of how we can think about what do we transfer between components of our graph. And you can see here, like, it's real straightforward, right? For our main agent state, we have our messages, some research briefs, raw notes, final report. For our supervisor messages, research brief, notes. The idea is that this is, again, compressing all of our context into this very specific state in order to make sure we don't go too far off the rails. And then finally, we're going to make our graph. Now, our graph is going to wind up looking quite simple, but we'll explore that in a second. Okay, this is the idea. Clarify with user. You can guess what that does. You're also going to notice that we're using the command templates, right? So these command templates are important to understand. This means like where do we go next? You can think of it kind of like a go-to, right? In older programming languages, so that's what this command is. But in our clarify with user, we just clarify with the user, right? Write research brief. You can guess what this is doing. So these are all of our nodes, and these nodes are important for the final graph that we're going to build. This lead research supervisor is kind of where a lot of the magic happens, right? So you can see here that we're going to have our supervisor go to the supervisor tools, in this case, we're going to exit based on criteria based on the research iterations, which means that we can kind of set these maximum research iterations. So instead of like dynamically designing, all of these tasks, we're looking at just the, a set number, and we can configure this in the configuration file. Supervisor tools, this is the thing that actually do the searches. You can see here, right? We have many tool calls. We have many, ways to search. And this is all handled, again, by our simple tool called node. There's a lot of code here, but I wouldn't worry too much about the volume of code. It's basically just searching. And then if we hit different, components or points, we're going to use our command to escape that node. Finally, we're going to build our supervisor. It's very easy. We have our supervisor builder, and then our supervisor, that's going to add our supervisor and our supervisor tools for our simple kind of, workflow that we discussed. So we go back to the diagram, right? This is building this set of nodes, right? Just a simple little research graph that allows us to define how deep we're going to go. And then finally, we create our final graph, which is going to be our researcher. And then we can see that configured right at the bottom here with our researcher tools, our compressed research node, and then our start and our final graph component, which is the final report generation, which is going to be leveraged when we build our final graph. Our final graph, of course, has clarify with user, write research brief, research supervisor contains the supervisor tools. We have, of course, our final report generation, and then we build our edges, and that is it. This is really all you need to do, right? So there's a lot of nodes, and there's a subgraph. But at the end of the day, this is all we have to do to build this deep research agent, right? You can imagine there's so much work we could do to modify and change this to make it even better and stronger and faster. But the basic idea is very, very, very straightforward, right? We want to start by clarifying with our user, write a brief that we can give to the thing that's going to do lots of work, right? In this case, up to n iterations of work, and then we finally build that report. And that's it. That's all you have to do to build deep research. This is not a lot of lines of code, right? 700 lines of code for like the core logic of the application ain't that bad. And with that, we'll go back to Dr. Greg. But before we do, I have to ask you to like and subscribe and ring the bell notification. We're here every Wednesday, and so we'll be here next Wednesday. Can't wait to see you. There you go. Back to Greg.
All right. Thank you, Wiz. So we're talking deep agents. Quick discussion, Wiz, before we get into conclusions today, though. I'm just curious. Like, we covered the deep research API recently, and I'm just struck by like all these deep tools we can sort of get off the shelf now. And it's very tempting to do this. When would you say, as engineers, as developers, we should think about starting to build our own, whether it's a deep research tool or whether it's a coding tool? And should most people be doing this today or not?
Yeah, I mean, I would say you should build a deep research tool if you need access to proprietary data, you're in a lockdown environment, you want to use a particular model for a particular reason, you want to use a language that's not supported, by other models. These are the main reasons I'd build my own. Otherwise, the off-the-shelf tools are great at this specific task.
Yeah, it looks like Ilona agrees. The local deep research
of it all.
Yeah. That's sweet proprietary, that PII, right? That's
right.
what people want. That's what the boss wants. So say, hey, boss, you ever use deep research? Pretty dope, right? What if we could do deep research with our stuff? And I think probably that'll make people care less about even using LLMs from OpenAI in a weird way. I don't have to give it all my files. I just have to let it look at them.
That's right.
Okay, and then what about coding tools, though? Should we just not be doing this with coding tools unless we work at one of these big coding companies? I mean,
you can do whatever you want.
That's dev environment setup level stuff.
But I would say just people are building great tools. If you're not passionate and specifically interested in it, use those great tools.
Yeah. Okay, good stuff. All right, thanks, Wiz. If you got questions, throw them into the chat, guys. In conclusion, deep agents, shallow versus deep, is probably about how much planning and acting over what time/context horizon is taking place. Shallow and deep will continue to evolve much like large and small language models. Inspired by Claude Code, we see that this framework is probably going to have to keep pace with Claude Code, such as the nature of frameworks out here. 4 pieces: detailed prompt, planning tool, subagents, file system. If we really plan all the way to the end first and we one-shot it, we can really do a great job. Of course, that's extremely difficult. Maybe it's impossible. So you're probably going to have to iterate to get there, which means you're not doing that at first. And if you are going to let these things run for a long time, you probably shouldn't do it without any human in the loop interaction. And then, by the way, there's this whole evaluation piece that we left out of this entire thing. And that evaluation starts with you iterating on this damn thing in the first place. So we do have a couple questions in the chat here, Wiz. So let's go ahead and get to these in the Q&A period here. So we've got, why is it so tough for others to implement clarifying questions? I'm not sure I understand that one. Like building a deep agent, right? And then the agent asks you, wait, are you sure about that? What do you mean by that, bro? Is that a best practice for these things today? Hold on, you're muted.
I'm hella muted. As we just saw, It's easy to do user clarification. We just did that with the open deep researcher from LangChain. So I don't know why it's tough, but it's certainly not a technical limitation.
I think it's an enterprise payment plan limitation. Okay. Mayu says, should deep agents do their own data gathering from the wild, or should we put them on Rails?
I mean, it just depends on the use case, right? So I would say though, you want some exploratory knowledge. You want some exploring to occur, even if you're in a rather locked down environment, whether that be totally sanitized environment or not. You want to have the ability to see information. So whatever your compliance needs are, you should obviously stay within those, but allowing the researcher to explore is part of what makes it good.
Yeah. Okay. And probably both, right? Both and get that sweet proprietary, and then be like, if you can't find it, just look. Okay, good stuff. Well, thanks, Wiz, for your expertise as always. We'll look forward to seeing Claude skills next week. See you back then. Peace. All right, everybody. It is time to wrap up today. Thanks for joining us for another AI Makerspace weekly Wednesday workshop. If you're still with us today, we hope to see you back next week. As I mentioned, Claude skills. Simply put, these are folders that include instructions, scripts, and resources that Claude can load whenever it's needed. Simon Wilson says they're, quote, awesome, maybe a bigger deal than MCP. In addition to seeing you again on YouTube, our Discord channel is where 3,000 aspiring AI engineers are chilling. Jump in, engage with them. They're a really cool, competent community. We're on a mission to create the world's leading community for people like you who want to build, ship, and share production LLM applications. And by focusing on really practical AI education, ROI for people like you and the companies you work for, building, shipping, and sharing, giving away our knowledge, and making it easy for you to give away yours. We hope that our entire community can embrace the LLM edge and focus on what we don't yet know, like we saw today, together. If that sounds like something you'd like to be a part of, welcome to AI Makerspace. If you'd like to accelerate your journey as an individual or someone leading a team, we'd also encourage you to check out our 10-week flagship course, the AI Engineering Bootcamp. Cohort 9 kicks off January 13th. The course is a live, interactive experience taught by myself and the Wiz, and it's supported by a large staff of certified AI engineers to guide you and give you feedback on your work each step of the way. We designed this specifically for full-time software engineers who are ready to go all in on AI. If you're an enterprise looking to adapt the curriculum and format to suit your production systems, use cases, and strategic deadlines in 2026, don't hesitate to reach out to me. If you're just getting into AI-assisted software engineering, check out our brand new offering called the AI Engineer On-Ramp. From vibe coding to AI-assisted development, planning is at the top of the list in that one as well. Cohort 1 kicks off in 13 days on November the 3rd. That's all for today, folks. Thanks for joining us, and until next time, keep building, shipping, and sharing, and we'll do the same.